Hi, welcome to the advanced tutorials. Okay, a fellow has come in. His name is Dill Penner. He wants a house built on his property just outside, a couple miles from where I live. He has given me a bunch of drawings that he's brought in, and we've scratched around with them. I'm going to show you here. First of all, I'm going to bring in, this is my drawing file. This is people that I work for. This is how I keep organized. If I go to Penner, open, and I scanned in his information, the stuff that we talked about. Okay, I'm just going to use Corel Draw here to do this. Okay, let's get up. Okay, we'll bring in the first scan here. Okay, well, there's a lot of scratch. Hopefully you can see. You'll have to follow my mouse here as I talk. Okay, so this is his basic drawing. It's a rectangle. He's given me some sizes. He wants 58 feet that way and 28 and a half feet that way. This, not necessarily the front of the house, but this over here is the road. It's in a large field. He has a really nice view going in this direction, if you can see my mouse. And so on this house he's going to attach a deck, and the deck is going to wrap around. His front door is over here. His driveway will come in through here. He's going to put this squiggly line in here as a retaining wall, and then we're going to build him a shop over in this area here. This gives us our basic layout. The scratch is just stuff that we talked about as we were working through this drawing. Okay, let's bring in another one. Okay, let's go to fit. Okay, this is a scratch drawing just so that I knew what was going on. This is his basement. Okay, this is underneath the main floor of the house, so concrete. He's going to walk out the back of it again into this large open field with the view, so he wants glass doors to walk out of. This BM is just a beam we're going to put right down the center. Floor joists are going to run from either side, and then we've just sort of done a little layout showing, okay, he'll probably have a bedroom over here and a bedroom over here. So here he wants windows. His gas and hot water heater will probably be down at this end. We'll give him a washer dryer area, and we'll figure out something for a bathroom down here, typically underneath the bathroom on the main floor. Okay, we'll bring in another one. So you'll have these files. You can print them out. I use them all over the place. Okay, this one needs to be rotated a little bit. So image, where's rotate? Here's rotate, and I want to go counterclockwise. Okay, so this is just a sketch sort of showing his elevations. His land is very sloped. So we talked about the road being at well, the front of the house, the north end of the house. This would be the road. So there's a hill coming down onto the road. And what he's worried about, his land slopes continuously down from the road. And he's worried about water running down across the road and then coming down into his basement. And so we're going to give him 10-foot high walls here, and he's going to backfill so he's got some slope going from 8 inches below the top of his concrete back to the road. Okay, and then we're going to step the basement, and so that he can walk out down at this level. Now we get to dictate on the plan how he's going to backfill all of this. As you can see, there's going to be lots of backfill. So this is just a sketch. This was another way of getting a 9-foot high or a 10-foot high basement, was to use 8 feet of concrete and then build a wall on top. But he doesn't believe that he's going to be able to get slope from this point back to the road. So we're going to do this all in concrete. And that's beyond us in the BC Building Code. What he's going to have to do is take our plans to an engineer and have that this 10-foot high wall with backfill up to 8 inches from the top of it, engineered. The engineer will tell him how thick that wall has to be, how much rebar it has to be, and so on. So we've already pretty much established that as we were talking. Okay, so another drawing. Again, this one needs to be rotated, but well, let's go ahead and do it. Rotate 90 degrees counterclockwise. Okay, this just basically shows the back of the house. Okay, so here he's got his foundation. This squiggly line would be the ground. He wants lots of windows. He wants a ceiling in the back end of this house that matches the pitch of the roof so that he can get these windows, these rake windows, up on top. And then here he wants a double door onto a deck. So that's all that was about, just to jog my memory what the back of the house wants to be. So this one, okay, this is a squiggly layout. This would be his house. This would be the wraparound deck. Now we're going to build him a shop over here. And we're going to put a breezeway, a roof, so that he can walk from his house, from that door, the side door, the front door, if you will, over to his shop, and he won't have to shovel snow because it'll have a roof over it. Okay, this one, okay, to fit. Okay, again, needs to be rotated, but it's just another graphic for me. This would be his shop. Here, let's rotate this so it'll make it a little bit clearer for you. Rotate. Okay, so this would be his shop over in this direction. This would be his house. The roof of the house is going to cover this deck completely. So there's some information off this drawing. It also shows that he wants a large garage door in this, and a small. One's for his wife's car, and the other is to get his boat into this space. And again, the roof between the two. Okay, so let's bring in the last one here to fit. Okay, I don't even remember what this is. Oh, this is the shop. Okay, let's turn it around completely. Okay, to fit, I need to rotate it. Rotate. Well, let's do one of those and then do another one. Rotate. Okay, so this is sort of the layout of the garage. It's going to be 30 feet long. It's going to be 28 feet wide. The door here is going to be 10 by 9 high, and this door is going to be 12 by 12. Okay, so there's some information that the roof will match the roof of the house, and of course there'll be a breezeway. So these can be printed out. They'll be a lot clearer for you when they're printed out. But anyway, that's pretty much what we're going to work with here. If we go back to his floor plan that we're going to start with, let's go to 100% here just so that we can scroll around. Okay, so that's a lot clearer for you. This is what we're going to work off of. Okay, we get to play with it. Okay, he doesn't know how wide this bedroom's supposed to be. He has a hallway. He has a main bathroom. We know that's going to be 5 feet because that's a tub, toilet, vanity. This ensuite area needs to be fairly luxurious. You can see he's got a big 5 or 6 foot corner tub in there. He wants walk-in closet. So that's going to take up a lot of room. He has another little bedroom, bedroom number 2, okay, here. Then he's got this pantry set up, closet for this bedroom. He needs an office with a corner, double glass doors he wants in there. Okay, this stair, we'll figure out his stairs. He wants the stairs 42 inches wide. That was very important. You can see this is his main door for coming in. And he'll have steps that come up to this door, not very many because he's going to backfill up to there, but then he's going to put in a retaining wall here, and he's just going to drop the elevation his finished elevation down steeply, and so that he can get windows underneath these windows downstairs. Okay, so we talked a little bit about the slope ceiling, and we are going to start here. Okay, we are going to, this is going to be a girder truss running across here to give him his, back in this area it would be a flat roof. Okay, back here in the bedrooms, pantry, and so on, the office. Okay, but from this area on is going to be slope ceiling. I originally put it here, but he decided to move back farther so that the kitchen had, which makes a beam from this point here to this point here, okay, which is huge. It's going to be a very expensive beam. From here to here we use rafters as opposed to trusses so that we can lift the ceiling up. Okay, here we've shown a good sized 12-foot deck that he wants out of here. We'll have to have a big post sitting here with a beam running across, and again rafters. And this red line here sort of designates, okay, he's going to have posts all along here, and so that this roof will extend all right over here, right? So cover this whole area, not just the house, so that everything is under a roof. Okay, so print that out and we'll get started drawing here pretty quick. Okay, rid of this file, or you should have downloaded a file called tutorial package. Now this has well, there's a backup because I've actually opened up a drawing here. I can delete this. Okay, we don't need the backup. Autocad will make backups wherever you open the drawing from. Okay, there's a basic drawing. This is going to be what we start with. Okay, it has all sorts of things attached to it. These are Lisp routines that we're going to use to make bifolds and doors when we're doing the plan. It's just a heck of a lot quicker. There's a window list that I may or may not use, but these three need to be into this basic drawing so that we can use them. This basic blocks is, we're just going to keep it separate, and I'm going to use the Autocad Explorer to find all these blocks that I need to do this. Okay, the basic backup, we can just delete the backup for now. Okay, the README text is just, as you download it, it'll have the instructions on how to load these various things. And I'm missing font in here. I don't know what happened, but we'll find it and we'll load that as well. Okay, let's go to basic drawing. Oh, we can't double click when we're making a video, so let's open. Okay, I'm working in AutoCAD 2000. You're gonna probably working in another version. I strip off all of my toolbars because, just like in the beginning tutorials, we are going to use commands, the command prompt. Okay, that is where that PGP file comes in. Okay, I'm going to work just off of my drawing here, and we're going to start with a rectangle that's 28 feet wide by 58 feet long. Okay, so let's go rectangle. RC gets you in there. Okay, we can go anywhere we want, but we're going to go at, which is that point that I started at, and we're going to go 28 feet in the X direction, comma 58 feet in the Y direction. Okay, so this drawing has, I'm just going to erase this triangle. Okay, or rectangle. This is our drawing. We're going to offset 6 inches the thickness of our walls, okay, on the main floor. So in Canada we use a method called stick framing, and we use 2x6 members for our studs. And again, this will come a lot clearer when we do a cross section of this building and show you how we're building it. But for now, just we are averaging out the thickness of our walls to 6 inches. Okay, so that'd be a 2x6 stud, and we're going to use 3/8 plywood sheeting on the outside of this building. Okay, so that's our basic layout. That's going to be his house, and we can start anywhere we want. Now you have to bear with me, I haven't done this drawing yet. Okay, so you're getting to start with me. First thing I'm going to do is explode, okay, so that now I've got all the different lines. And okay, we're at the back of the house where we're going to do this bedroom. And what am I going to do? Where am I going to start? Okay, well, a nice sized bedroom would be 14 feet deep. Let's do that. Offset 14 feet. Okay. And then the wall is 4 inches thick. Okay, so that gets me to this office. No, that gets me to this bathroom, and we know what that is. That's 5 feet from wall to wall. Okay, all bathtubs, standard bathtubs are 5 feet. They will be framed, the wall will be framed, the bathtub will be put in by the plumber at that point, and then the drywall, the finish on the inside of the house, will actually wrap on top of the lip of the bathtub. And so offset 5 feet, and then 4 inches for an interior wall. Okay, the reason that interior walls are 4 inches is we're using a 2x4. Okay, and if you're not familiar with the way that we do things, when it comes out, when the wood comes out of a sawmill, it'll be cut at actually 2 inches by 4 inches rough cut. It is then dried out, run through a kiln, dried out, so it'll shrink, and then it's run through a planer to give the nice smooth edge. And so by the time it comes to us, or comes to the builder, it is actually 1.5 inches by 3.5. Okay, we use drywall, 1/2 inch drywall to finish off the insides of our buildings. It is typically a 1/2 inch thick. We use 5/8 and fire guard drywall in some applications, but on a normal interior wall in a normal house, so it'll be a 1/2 inch. So if you have 3.5 plus a 1/2 inch drywall on either side, that would be 4.5 inches. But we just calculated at 4. And then we compensate for it. So basically, we are only compensating. We are only building. We are only designing with one side finished. Okay, so a 3.5 inch wood stud and a 1/2 inch drywall makes 4 inches, and that's what we design with. And so a framer, the fellow who actually builds this house, puts the wood frame together. Has to understand, or has to have that knowledge that when we've left 5 feet, that actually is from wood to wood, because the drywall will go in later, and the finished width of that bathroom will be 5 feet minus 1/2 inch on either side, drywall on either side, so would actually be 1 inch less. Okay, so these are just sort of industry standards. Same with the exterior walls. You know, we said that we were using 2x6. Which would actually be 1.5 inches by 5.5. We're using 3/8 plywood on the outside of the house, so the walls really are 6 inches. But when the fellow frames it, he goes to an outside dimension, and that's all we give. Okay, so in actual fact, the house will be a 1/2 inch narrower on either side, because we haven't accounted for the drywall. Okay, it's just so that if you try to figure out what we're doing here and you actually calculate everything and you say, hey, our walls aren't 4 inches, walls aren't 6 inches, well, they are for designing purposes, okay? And you just have to keep in mind that the trades know what they're doing and are accounting for the discrepancies, okay? And we have to be careful. Again, this 5 feet, okay, and then 4 inches on either side. We just know that that's the way that it works. Okay, enough for that. Let's go on to the next area is an office. Okay, well, if I look down at his drawing and I left 14 feet for the master bedroom, the office is a little smaller. Let's leave 12 for now. That'll be a beautiful sized office or bedroom. So we're going to offset 12 feet. Okay, and then we're going to go 4 inches. Okay, so we zoom down a bit, and you just sort of have to use your eye. Like, I have maybe a little less than half the building left, and if I look down at his drawing, I'm pretty proportional. I didn't do that bad a job at the guesstimate, and for now I'm going to leave it. I mean, the beauty of working in AutoCAD is that we can change things, move things, stretch things. This is just a good way to start. Okay, now we get to this front entrance, and there's a couple things with the way that he's drawn it. I don't see a closet. Okay, he's got L-shaped stairs and a bench, where he's calling up a bench inside the thing. Well, we can take some room out of that office if we want to put a closet in, and we can talk to him afterwards. This is a preliminary drawing. Already we've noted that there's no closet space. We can mention that to the owner, or we can go ahead and draw in some later if we think we have enough room. Okay, that whole sort of width between this office wall and where the stairs start to go downstairs, I'd like to leave it at least 6 feet. We could get a double door in there if we liked, if he wanted, but it gives enough room for people to move around. So let's do that for now. Let's go offset 6 feet, and we'll take that one in there. Okay, that would be the start of our stairs. Now we've got some calculating to do here. He shows 1, 2, 3, 4 risers down to a landing. He split the landing into 2 steps and then continues on down. Now, we already talked about he figures he'll need a 10-foot high wall, or he'll need a 10-foot high ceiling in that basement. And so there's a couple of things that we take into consideration. So 10 feet, okay? Now it'll be a little bit less by the time we pour the concrete. And he's not really sure. I mean, he has to dig down, and his reason for doing all of this is that 8 inches below the top of the concrete, he wants to start his finished grade, his front lawn. Of course, the farther back he puts his house from the road, the higher he'll have to go to grade it down at a reasonable grade where water's going to run, so at least an inch every 10 feet back to the road. So all of that's going to be done on site. Okay, and it will. I mean, if he's having an engineer work with his 10-foot high, it wouldn't be any difference to work with 10'6", just because he's on site and he's standing in his hole and he's taking shots of the elevations, and he decides that he needs even a deeper basement, right? Which of course will affect the stairs. Okay, so we're going to work with 10 feet now from a design point of view of ceiling in the basement, and then we have to account for the floor joist, so the actual thickness of that first floor, the ceiling of the basement or the first floor of the main floor, the floor level of the main floor. Okay, now we're only 28 feet wide, and we know that we're going to have a beam running down the middle, so our spans are only going to be 14 feet, which are really not big at all. So we're going to calculate, just out of experience, that we're going to use something the floor that's about 10 inches thick. Now, he's talked to me, and we think that we're going to use I-beam floor trusses. But even if he does, which are 9.5 inches, but even if he uses dimensional lumber, 2 by 10, again, we're going to be down to 9.5, 10 inches, and then a floor on top of that, 5/8 plywood on top of that. So back up to about 10 inches. So from a design point of view, we're going to use 10 feet, which is 120 inches, 120 plus the 10 inches for the thickness of the floor. And so that's about 130 inches. Now, we like to keep our steps at around 7 inches per step. in height. So a rise of about 7 inches. And we're starting with 130 total. So if we divide 130, so we divide by 7 inches, it tells us that we can do that 18.57 times. Okay, so what we're going to do is we're just going to make 18 risers, and they're going to be a touch over 7 inches each, probably about 7 1/4. So in fact, if I do that, if I do 130 inches divided by 7.25, or sorry, if I do it the other way around, I do 130 divided by, we figured 18 risers equals, oh, my calculator is 130 divided by 18 equals 7.22. Okay, so each rise will be 7.22. Now if we have 18 risers to do that distance, right, the 10-foot ceiling and the 10 inches of wall, 130 inches, where just after you've designed a few set of stairs, you just actually know that you're going to have one less run. Okay, so a run, the tread, we are going to build out of 2 by 10, and we are going to have each run will be 10 inches. Okay, and so we can start designing our stairs here. We know that each run is going to be 10 inch, and we know that we have 18 risers. Okay, so we just offset 10 inches. Okay, okay, so there I've accounted for 2 risers, 1, 2. Okay, he said he's got shown here 1, 2, 3, 4, so let's do that. Let's do, okay, we'll get back into the offset command, 10 inches, and 1, 2, 3, 4. Okay, now he's told us that he wants his stairs 42 inches wide, and so this next landing that we're going to draw here will be 42. So we'll get out of it, we'll go offset 42, and offset 42. Okay, so that's actually the wall. That's actually the outside edge of our steps, so we'll offset 4 inches. Now, he has told me that he doesn't want a railing, he wants a half wall at that point, so that people don't fall down this stairwell. That's fine. We'll do that. Offset 42 in this direction. Okay, so that gives us a lot of information there. If we trim, if we clean this up, okay, that's the width of these stairs going down. Okay, so there they are, 1, 2, 3, 4 risers down, a 42-inch landing in both directions. Okay, now we can trim here too, make that a little nicer. Okay, now we can start going down the other direction. Okay, so offset 10. Okay. Okay, I'm not counting here, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, it's getting to be, you know, okay, 15, 16, 17, and I don't like this when they put a, what they do is they build this landing and then they divide it in half diagonally and have a step, and I don't think it's very comfortable, but he doesn't seem to mind it, so we'll do that. So now we've got 1, 2, 3, 4, and then 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, that's good. We'll draw a line from, oh, I have old tracking on. I'll just turn old tracking off. I want to draw a line from there to parallel over, and then I just want to trim. Okay, and I want to trim to this. I'm going to use a fence, F for fence, and I'm going to go across to there and get rid of those. Now if I zoom in a little bit, okay, there's sort of the layout. Okay, now we at this point, there's only going to be one way to sort of explain this next. Okay, so that's a half-an-hour tutorial. We'll continue with the stairs in the next tutorial. Thank you.